Computer, great. And we're going to see what other things we have. All right. New math fun. Oh, I can show you the 2400 uh, assignment 3. Or assignment 2B. Start a file. Do a solution version 2. Great. All right. And I can start sharing my screen. There we go. I'm also going to pull up the chat window just so I can see what you guys are writing at the time. Okay, C++ file opening in strings. Great. Okay, so we're going to go through what I have to relearn every single time, just like I relearn strings every single time. In case you wonder why I'm being so cavalier about it, just because I'm used to doing this, and I think most programmers are. You just purge crap out of your head and then you go and relearn it again later. Now, but the first time, scary. So let's go over a little bit of that. So I'm going to make I wanted to point out here is the new version of the code that provided, just because some of the string equivalents to a lot of functions, it started getting a little in the weeds. And I didn't want you guys to have just, we're trying to get you exposed to and trying out new things, not panicked and overwhelmed with some weird fiddly detail in your code. There's already enough things that can go wrong in your code. I don't need to make it harder necessarily. So we're at least trying for that. There's a fine line between where you learn and where you get overwhelmed, right? And below that, if you're not learning, you're just like, I know how to memorize how to call an ifstream. Um, so I actually provided this thing right here, which is the remove comments CPP function for C++. So I have the same thing, remove comment C, and this function is called remove comment CPP. One's for C, for 2A. This is for C++, CPP, C++. That's why they're CPP files. And in this case, we have uh, an input string or an input file and optionally an output file. My actual solution has an output file. I just kept on putting uh, little comments here. Hey, by the way, if you're doing the output file, you would pass in another parameter in here, essentially. Okay, I want to not do just give you answers. I know maybe you want me to do that, but I don't want to do that. So let's try something else. Um, think lecture uh, file reader. All right, and I'm going to play around with this. And so what we're going to do is I'm going to read in a file, write to a different file, the exact same content. I'm going to go line by line. So um, read line by line and write line by line. We can also do like character by character, or tab by tab. Fairly easy to do. Uh, let's try that as well. Maybe also by um, token by token, as in up to white spaces, like scanf works, right? C out and C in actually do that job, the exact same job as scanf did before. Fscanf, we have something similar to that, so we're going to do similar things. The the streams that we're talking about are file streams. A stream, like a river, when the stream goes by you, you don't recognize where the water is. The water just keeps on going. Nothing's really stopping it. That's why it's called a stream. It just keeps going, flowing. And all you're doing is getting the next part, the next part, the next part, the next part. Every time I get a line, it's the next line, like a stream of a river. And so what we're going to be doing is, and again, if there's something in particular you guys want to talk about and I'm going off topic, please let me know. But what we're going to do is go open a file and just read a bunch of lines from the file. And I'm going to output those same lines, those text lines, strings, to a different file. So let's try that. So um, let's see here. I'm going to do number of lines, let's say, and let's make it a size just because I want to show you this. All this size t is, it's an unsigned integer. That's literally what it maps to. It's defined size t as unsigned integer. The whole point is I don't want to have to write unsigned integer. I want something variable that looks like kind of punchy and looks nice, right? Could have called it a uint for unsigned integer, and that would have been just as fine. It would be the exact same thing. Okay, so I'm going to read write test as the name of my function, and I'm going to have a string file in, string file out. And what am I going to do here? So first of all, I'm going to take the same things that I had before, and honest to God, I forgot how to do this stuff myself. I looked it up like when I was doing this, that hour it took me to re-implement all of this stuff. It was like, how do you do a file stream again? Oh, let's look it up. Right, that part of that 1 hour was me doing a quick search as well. Okay, so I'm going to have an input stream and an output stream. I need to open that input and output stream. And when we look at, I'm not even going to do that pointer. Am I going to do a pointer part of it? Yeah, I'm going to do a pointer part of this. Or I could just do this. Uh, there we go. Let's do it this way. It doesn't matter which way we do it. When we talk about objects later on, we will be calling new to make a brand new object, and then we have to call delete to clean it up afterwards. If I don't call new and delete, much like when I have an array in before, if I have a static array, I don't have to call malloc or free. I just have a static array and it automatically gets cleaned up. If I call new, I got to clean it up, which by the way, I think I'm probably thinking I've messed up here. Oh yeah, I did. Nice. Okay. Or I should be adding it in here. So um, just in case you're wondering, for your actual solution, my suggestion, this is a pointer, so I'm going to, that's what I do. Delete, delete, and I would normally, not the else, that's not in the else condition. I should be putting it up here after I have closed my file. I call new, I call delete. That's effectively what I end up doing all the time. Actually, I should call delete outside of here. I was right the first time. I'll call close somewhere else, but if I call new and I get a new file, I should call delete. And I would also need to put it in here. Okay, this is just for me later on. I'm going to keep it like this. I'm not even going to call new. I'm just going to have an input file stream, ifstream, input file stream, ofstream, output file stream. They're lazy, but there's a reasoning and a logic behind how you build up, how things are named. And because we're so darn lazy, and I strongly encourage efficient laziness on your part, in file, and I forget the name of things. Okay, let's look what I have. Right, that's literally my job. My job was, as a professional developer, my job was type in the name of your object that you have, push period, see what options you had. I mean, it was that a lot of the time. A to probably not this, but open seems like one of those things that I might use. Now that seems like a variable. What I'm going to probably have is something like open in here. So let me look at this. EOF, by the way, stands for end of file. Exceptions, fail bit. Okay, let's see what I get here. Good. I can even just start typing in things, but I wanted to walk down this thing. Open. Hey, that looks like a function called open. Okay, it's going to take in, um, and it's going to take in a bunch of different things. But let's see what it will take in. So if I just start typing in, it'll take in a file name as a string, and it'll take in a mode. Let's see if I need the mode. Let's find out. File in, and what does this thing return? I'm going to hover over it. It's not really returning anything. Okay. Then there's probably some way of checking to see if it's open. Okay. What else do I want? Uh, and I want out file.open. I'm going to open up this file and file out is the name. And I'm just checking to see if I have any kind of error. Do I need to know what kind of extra parameters? Maybe I would do a Google search if I really needed it, right? There's different modes that you can read in. You can read in binary mode. Defaults are often good, but sometimes you want to explore. So the first thing I want to do is I want to test it to see if it works. I want to do the minimum amount of work to see if this thing works. And if it doesn't work, yeah, then I need to do something else. Okay, so I want to check to see if this thing is open. So if my in file dot is open, let's say, that sounds like a pretty good function. Is it open or not? If it's open and out file dot is open, I want to check if that's open. If they're both open, then I'm going to read the file line by line. Otherwise, I'm getting the heck out of it here. Just I'm going to return 0, right? The number of lines that I have here. In fact, I probably should do this. Size t num lines is equal to 0, and I'll just return num lines. Every time I read in a line, I'm going to increase that number, and I'm good to go. It can be part of the bonus bit, yeah. So yes, that to be very clear, the outputting is completely bonus. If you don't want to output a file, don't just see out. We'll also see out these statements just to see what we get. Why not? See that in action too. And then we'll also try doing little tokens as well. Okay, so I'm going to read in the file line by line. So let's read it in line by line. So I'm going to have a string. This is our new fancy pants type of data. It's not an array of characters. It's a string. That's a string. It seems like a basic object. It's not. It's an object. It's not a basic variable type. It's an object. And we'll get to objects very, very soon. We've already sort of hinted at it in the videos, presumably that you've watched. Per line, let's call it. And then I want to see, oh, I'm just going to need to keep this around. Okay, we're going to have to look at that Discord post in a second. Sorry, folks. I'm also going to sign up that my Discord. Do not disturb. Okay. Um, so what else do I need? Well, let's find out. So I mentioned in, I think, in a post recently, I think I even said it in here how to use it. Use getLine. There you go. That was what I found a little weird. I'm going to call some function called getLine, and getLine happens to take in an input file, and it's also going to take in the string that I'm going to be writing to, presumably. And that's going to be per line. Let's see if that works. Hey, seems to work. All right. So if I read this in, I want to see what this thing is going to spit out. And so maybe I'll do a cout statement, and it'll be current line colon. If you have not seen cout statements, this is what C++ programmers use all the time. This is why printf is weird. Our cout statement, it is actually uh, what is it? It should be a global object that you have access to, or maybe it's a static function. I have to figure that out. The class that it's the standard library. It should have a global object. I think it's that it's using. But effectively, the way to look at this is this thing is getting shunted. Notice the arrows, they're going that direction. They're going out. And then this thing is getting shunted into this thing, which is then getting shunted into this thing. It is just the end line, end line, gets put into the current line. The current line and the end line then get put into this thing. This thing gets put into output to the screen. So push down the way. And so I'm just outputting a line. I'm going to output each of the lines, and then that's it. I'm not doing anything else. I'm going to close. I want to make sure I close off my files. So infile.close. Okay. Uh, outfile.close. And I'm going to just stop what I'm doing there. Not literally my demonstration. I just want to see that this thing works. Before I move on, I'm not coding up all of this stuff and then seeing. I'm going to go to my main, find wherever the hell my main is. I got so much code. Okay, let's throw my main. Here's my main. All right, so we're going to throw in this thing here. And, oh, there we go. Should undo that for a little bit. Lines is equal to, I'm going to read in this file. I'm going to, oh boy. So I need a string. So I can make a string in file, and that is going to be, uh, let's use my handy dandy text file.txt. It'll be the same thing each time. Okay. Sync demo.txt. That'll be the name of this output file that I'm eventually going to output to. I'm not doing anything with it right now. For the time being, this will make, in case you're wondering, this will make a new string called in file. That's what it does. All right, and my output file. There are other ways of initializing a string, but this is one way you can start up a string. I'm making a temporary string called in file, a temporary string called out file. I'm going to pass it into this function right here, and I'm good. In the assignment, I'm passing in string pointers. So I just get a pointer to the string and pass it in. It just means that I can modify the string object. I can modify the string and it gets saved somewhere else. But if I know I don't have to save or change the values around, yeah, use a parameter. That's fine. All right, let's see what this thing actually is going to do. Read write test. Oh, identifier not found. Of course, the identifier is not found. Why? Because we didn't do anything. We didn't make a prototype of it. Let's make some prototypes. Here we go. We'll have that as a, yay, there you go. I didn't replace it. This is what I copied earlier. So here's a prototype of the thing I'm going to be testing out. I wrote it all the way down to the bottom, but I'm testing this thing up here. All right. Hey, it worked. Great. Let's find out what this thing does. So I can either just run it and see what happens. That's probably will work just fine. Let's just run it and see what happens. All right, I got to move this over here. Okay. So what is this doing here? That seems like it's reading in something a bit early. Let me look into this. That is weird. Okay. I want to see what the heck's happening, but for some reason, oh, this is a test. Okay. I'm gonna put a breakpoint in here. Make sure that's all funky, all well and good. Okay. Hit the breakpoint. Great. I'm going to walk into my breakpoint. That is the step into function or the step in option. Uh, okay, I'm in here. I'm going to have an input file. Great. I have an output file. Great. I open my file. Hopefully that's going to be fine. Number of lines read in. If the input file and the output file are both open. Okay, that worked. So just stepping through this line by line, I'm going to, here's a new string. I'm going to get the line. I'm going to put that text into the string. Now remove text after the slash slash word. Oh, it is that. That is what the that is what the output was supposed to be. Great. Current line colon, and then I should output this text here. Now remove text after slash slash or a /star, and then put in a new line. So I should have a bunch of things saying current line, current line, current line, current line. Yeah, statement. Oh, I'm only doing it once though. I've only called this one time. I need to, if I want to do the entire file, I need a while loop. All right, that's fine. I can do a while loop. So let's just continue on and just be done with it. So here is what this function we've been doing did. Oh, sorry, you can't see that. Here we go. There it is. That top line right here. Current line // now remove text after // or a /star. Okay, that's fine. We didn't really do anything fancy, but good enough. We know that that stuff works. I know I opened my file. I know I opened my output file. I know I can access a single line of text. I want to know how many times I'm going to go through this file. So I might want to do something like, so here we have a current string while in file dot end of file. I found that weird. I didn't know about this, but there's some weird times you need this. End of file, EOF. If it's not end of file, and what else do I? So I'm not at the end of the file. I also want to know in file dot. What if I get the line? What does get line do? So not in file get line. Let's just get line because there's something weird about this. Get line in file and per line. So what if I get a line of text? Instead of calling it down here, I just plop it in my while loop. What would happen? Well, first of all, I want to find out I'm going to move this around. All right. So what would I expect here? I expect I'll stop when I get to the end of the file. What does get line do? And this is the reason you would not necessarily see this right away, but it returns an ifstream. It returns the stream itself. What? But if you look at examples online, which is how I discovered this, if you look at examples online, what you end up seeing is like it returns either null or not null. Essentially, null if something bad happened, you went past the end of the file, or the original file stream you've been playing with the entire time. The way you know you've gone over the edge is if you get a null and like, whoa, bad things happen. Otherwise, leave it alone. Leave it alone. As long as it's not equal to null, you're fine. So you could say not equal null. That's the same as saying get line. This get line here. I'm going to also move. It should do it there. But I don't know why this is giving me. Huh. Base stream is not equal to an integer, but I don't want it. Is it not an integer? It'll be equal to null if it's false, but it's not. Let's find a 0. Let's leave it alone the way it was, every time I have seen it, which is if something goes wrong, this thing is equal to null. Otherwise, everything's fine. All right, but again, I don't know for sure, so let's find out. Hey, it barked on me. Great. I can deal with this. All right. My get line, I'm missing a paren. I probably don't need the extra parens, so let's get rid of one paren here, one paren here. Find out what's going to happen. A little bit at a time. Hey, it worked. Okay. Let's see what we spit out. We should get current line and all the various lines for this entire file and then stop. That's hope. That's the hope and the dream. I'll turn off my breakpoint here because it's just going to keep on stopping me. And here we go. Current line, current line, current line, current line, current line. Okay. It gets to the end of the file and stops. Good enough for me. Okay. I know it's I know it safely went through every line of the file. I output the output of the file. I saw how things were working. Great. Good enough. Let's do, uh, and we'll do one little bit. I don't know. Where am I? So I'm moving around a lot, but there you go. This is the file, the function we were working with, right? I'm going to keep on doing that cout statement. I want to output to the output file. So uh, I can actually do the same thing as my cout statement, but instead I can do, say, something like this, current line. And the weird thing I found out today was getLine does not include that carriage return each time. So those have all been stripped away. So I probably should add a new line. Okay, let's compile this. I'm going to also, once we run this thing, we'll get a new file. So I'm just going to look at how this works. Oh, okay. And I'm going to see if my new file, add existing file. Let's see what I have here. New text file. Is that our, no, we're looking for sync something or other, weren't we? Sync demo. There we go. So see what sync demo does. Okay. And our test file looks like that. And our sync demo looks like that. That file did not exist before. All I did was rip out line by line from the original file, just read line by line, didn't modify the original file, just read line by line from the original file, stuffed it in another file. That's it. There is nothing special that I did besides that. Just pulled it off line by line. Notice that strings, it can be printed to, you can modify. Heck, we can actually remove, let's do something crazy. Let's, we're gonna do something crazy here. Let's see. I'm going to remove the letter A from all of my Y. I don't know. I'm sure there's an A in there somewhere. Maybe question. Oh, all the question marks. I'm going to remove all the question marks from each line, and because I can. And then, so I'm just going to remove everything up to the question mark and then everything after the question mark, for example. So let's see what we can do here. So I have a line of text. What I need to do is do another while loop, I think. So I need to figure out if there's a question mark in the text. And if there is, just remove it. So if there's no question mark in the text, I want to move on. Otherwise, if I keep on finding a question mark in the text, then yeah, that should do it. Okay, so let's do this. While, also, yeah, while will work just fine. I normally have a true and false condition, but what I could do is something like this. So cur line, and then say dot, and then see if I can find something. So let's say find. Oh, hey, look, there's a find. Great. There's a find function. I can pass in something like this. Find the question mark. This thing, if I hover over the function, says it's going to return. Okay, it's going to return a size t. It's going to return some number, the location of where that value is. It turns out the location of that value, if it doesn't exist, is technically -1, but it could also be interpreted a whole bunch of different ways. So, um, so while this is, its size is always a positive integer, so that gets a bit weird. But while this, I find a positive integer, so while this value is less than cur line dot, hey, I have something to figure out the length of a string as well. I don't remember these things, I just look it up each time. So I find out the length of my string. If the position of that question mark is past the length of the string, it means it didn't find the question mark. Otherwise, it tells me where it's located in the string. Okay, so while this question mark is still being found each and every time, So I better get rid of this question mark every time I do this. Otherwise, I'm going to be in real. Oh, may want to save this as separate. I could do a do while loop, or I could do this. Size t question pause is equal to that. All right. If question pause is less than that, then I know it's a legitimate place. Maybe what I could do is take the characters before the question mark, take the characters after the question, all the text after the question mark, so just missing the question mark, squish them together. Maybe that's what I want to do. So let's pretend that's what we want to do. So pre question is equal to cur line dot substring substring. There you go. I'm going to string from 0 to question pause, and I'm going to get the post typing post question. I want all the text after the question mark. Okay, so current line dot substring. This is going to be at the question position plus 1, the next position afterwards, and all the way up to per line dot length, the length of my entire text. Okay, that's kind of weird, but let's find let's see what this does. And then maybe what I want is per line is equal to oh, I could do this pre question plus post question. Yes, you can do, it's not arithmetic, it's concatenation. I'm taking those two strings and squishing them together. I have a built-in function for that too. I could have also used append, appending two strings together. We'll look at polymorphism very, very soon for that. So I could do this sort of thing, or I could call append on this thing. Let's find out if this is going to work. And so what this should have done, and I want to put a breakpoint because this thing could go off into infinity here for me. So let's drop a breakpoint in this. What I want is every time I find a question mark, take the rest of the text, remove the question, and essentially remove the question mark, and try again. Find the question mark. Every time I find a question mark, remove all the text around it, squish them together, new string. And then I'll output my current line and put it into a file. All right, that's compiled. That's good to know. So let's find out. Let's give it a go. All right, we have something with a question mark in here. The current pre-question is slash t, as this is, and why is this not commented out? There should be a question, and why is this not commented out? Okay, there's presumably a question mark. Oh, there's a question mark afterwards. There's a question mark. Oh, that's interesting. Unless yeah, that's interesting. It's giving me just the question. So why is it giving me that question? And question pause is equal to, I don't want to have the hex value, 59. Okay, so it's going from position 60 and however long this thing is. Do I have that option? I don't have that value. All right, so this actually might go off to infinity. I'm going to stop my compiler right here. I'm going to stop the process right now because the question, the post question, I should be getting rid of that question mark. Otherwise, things are going to go real bad real quick. Why is it not finding? When I find the question mark, does it position this? Finding this question, but it should be everything past that point. I'm interested in this one. Okay, let's find out. We're going to stop this for a second. Y plus 1? That's my question. Close question. That's a 2 question marks? Let's have a look. That could be it. Yes, it's 2 question marks. Okay, let's go back. Oh, my algorithm was right the first time. I just had 2 question marks in a row, and I assumed I didn't. Next time around, I'm going to squish them together and remove and go through it again, remove the next question mark. Is it slow? Absolutely. You could do it a million times faster than this or better than this, but I'm doing it, it'll still work. All right, let's see here. I have a breakpoint right here. I'm going to, I get my current line is now equal to this with 1 question mark. I loop around, I get the, oh, I don't have that. I need to do one more thing. I need to find out if I have another question mark. I have to find this position again. Find where the, so I need to find question pause again. It's not, I'm not making a new variable. I'm not making a new variable. I'm using the old one. I have this new current line. I find the next question mark. It's now at the end, and I'll remove it again. That's what I should be doing. And I want to make sure I don't get an infinite loop, but if you do, not the end of the world. All right. So it's annoying, but it's not the end of the world. Question mark. I find the next position, position 59. I go around again. I go to the next question. Pre is this. Post is blank. It just quotes together. I combine them together. Current line is now without a question mark. And I try and find a question, and oh, wait, it's a huge number because it's -1. But it's returning a size. It's returning a only positive number. It just happens to be the largest possible positive number you can get when you miss the mark. If it's not found, it goes, oh, it's not in there. That's how it indicates it's not in there. Okay. I now finish my loop. I output my current line. I get the next line. And I should be able to just keep on running this and see what happens. And now here is my sync demo. Here is my original. Question marks are gone. Question mark is gone. I could have chosen any character and I would have just removed that other character from the file. There are no question marks anywhere in here, but there are in here, in the original. Okay. Uh, so good. So for pre-question, oh, this is, I'm assuming in relation to what I thought was wrong about. Uh, with pre-question, I'm going to start at position 0 and take everything up to, but not including. This is one of those things I would have tried it and then I would have looked at what my output was and gone, whoa, I'm missing that last character. It doesn't include the very last character, unless I'm wrong. Let's have a look again. Commented out, commented out. I'm including the last T. I would need to include that last T. If I did -1, it includes the first character. It does not include the last character, essentially. It's because we are also, it might be the length of the characters or the number of characters you're doing. Depends on how you want to view it. But most of the time we do inclusive on one end, on the left side, on the early side, in the including parts, and exclusive for the upper range. That's fairly common to see. And everyone gets it wrong and everyone just goes like, what is it? Let's try a different thing. Oh, it does this. Okay. Sort of figure out the function as you go. Okay. So we have this. What else could we do? Um, let's let's go through the file and pull off all the tokens instead. So um, let's just close all of this stuff off. We'll just comment all of this stuff out, because I want to see what happens here. Oh, num lines, I got to do that. So each line I have num lines plus plus. And then I want to return the number of lines, but that's something for. All right, my if statement should be down here. Mm, I don't know if you can hear my son talking very loudly. He's loud like I am. Okay, so let's see if our the streaming thing can like pull off individual tokens. Let's see what happens. You know. Okay, so let's see. Do this. If it's open, then I want to see string cur word. I want to make a string that's called current word. Just a string. It has a bunch of functions. It has a bunch of data. That's what an object is in object-oriented program. I just want you to expose to it before we deep dive into this. Okay, so besides that, let's see if in file, can I do that? And cur word, and let's see what happens. Is it letting me do that? It seems to be letting me do that. Okay. Um, and while in file dot eof, I'm going to do this. While we're not at the end of the file, I'm going to get the new word, and then I'm going to see out to the screen per word, and that'll do it. So it's just going to be. So what is this? Um, Latin text to one giant word. This is what I'm expecting it to do. I have a hypothesis. I'm going to remove each individual token. It's going to stop when as soon as it gets to a space. So whether it's a tab, whether it's this or whether it's that, it's just going to get rid of all the white space, any white space, a carriage return, everything. Every time, just like when we use scanf, as soon as we got to a white space, we stopped. This is going to work the same way. It's going to put in a, the next token, if you will, into current word. And then I'm just going to output current word onto the screen, hope for the best. Okay. No new lines, no new nothing. It's just going to be a whole big bunch of text. That's what the plan is. Let's find out if it works because I'm kind of excited. It's not, by the way, it's not even writing it to a file right now. It's just outputting it to the screen. All right, let's see if it outdid what I expected it to. Oh, look at that. Hey, it actually worked. The miracle. Okay, let's see if that actually worked the way I expected. Now remove text after a blank or a blank blank, and this is also a test, as this is also, and that seems to be exactly what I wanted. It's removed all of the white space in this entire text. If I take, let me move down here and move this here. There. Here's the text. Here's the text that's being output. It is this with all the white spaces, tabs, everything just removed. There's some tabs in here, by the way, in case you didn't know, like right here, there's a tab. But all the tabs, all the white spaces, all the carriage returns, everything. Because that double arrow works like scanf. It only does one thing at a time. It's visible text, one piece of visible text at a time, which is kind of limiting in some ways, right? If I want a whole bunch of words, fine. But if I want tab delimited, and someone's using space, it'll throw off my scan, which is why we couldn't use scanf in 1400 as well. I'm not going to output it to a I'm not going to output it to a text file because that's really not all that useful to have this much just random text. I could put spaces in between, so I could do something like, oh, let's do that. Um, so let me play with this thing. Okay, I'm getting each individual word, right? Let's do per word. I'm going to append something. Append, and I'm going to append, uh, let's see, a tab after each one. onto this thing, and then I'm going to output it. So I'm going to have a whole bunch of tabs in between each of these spaces, not character returns. It's going to be one long line with a whole bunch of tabs in between each word. Where there was a space before, now it's a tab. Or I can, maybe instead of a tab, let's make it a dash. It'll look prettier. I'm going to put a dash in between each of these words. So it's just a whole bunch of dash words. Okay, and then let's also do something else. Let's also, we can also do that remove. Let's see if remove all actually works. Remove, is there a replace? Is there a replace? Let's see what replace does. What does replace do? It takes in a string and it's going to first to the last constant iterator. By the way, I like pointing this out. What the hell is this thing here? Does anyone actually figure this out? I'm going to wait for this one because I think I've been talking too much. Does anyone see this 3 of 11 thing that hopefully you're all seeing on the screen right now? What the heck is that all about? Anyone have a guess what this is actually doing? Or maybe better yet? Yep, perfectly fine to have no idea. Most students, parameter variations. Nice, Ethan. Uh, and the function can have different parameters. And it's perfectly normal to know what the hell that's about. When we get to polymorphism, this is the example. You can have the same function with different inputs. They're all named the same. And it chooses the right function for the right job based off what parameters you give it. And that's extremely useful because what I want something to, I want to replace something. I just want to call the function called replace, not replace 1, replace 2, replace 17, whatever the case is. If I have 11 of these things, I would have to have 11 different names or a whole bunch of functions all named to replace with different parameters. And it calls the right one for the right time for the right job, which can be intimidating when you see 11 of these things. But most of the time you just go, I'm going to replace what? I'm going to try something here. I'm going to replace the question mark with um, exclamation point everywhere. So everywhere, uh, hopefully that's going to work. Does it work? It may not work. I may have to look into how the heck to call this thing. Oh, it's because it's not a string. Um, should do that though. Hopefully that's going to work. Let's find out. Does that work? Nope. I'm gonna have to find out how the heck this thing actually works. Replace. Do I have a replace all? No, just replace. Resize, rand. Resize, by the way, should change the size of your thing to make sure that the amount of extra buffer space you have for a character, for the number of characters being stored, yeah, they have some extra space in there to fill in so you don't have to constantly make a new array. It can resize it. I can compare two strings together. I can also use double equals if I want. I think double equals works. It's overloaded. Um, but there's so much stuff in the string class. Just look it up most of the time. Assign, okay, let's see what assign does. It's going to take it, we're dealing with iterators and it's going to get kind of wonky with iterators. I don't want to get into that. We're going to have a whole bunch of class afterwards about iterators. I don't want to get into it quite yet. What is begin with? Capacity, how much it can store. Uh, Clear, that's going to remove all the text, all the characters from my array. I can compare, I can copy. Let me see here. Is that empty or yes, it is checking to see if it is empty or not. It's empty, huh? Right. Empty question mark. Can erase a particular part of my text with a particular offset. So erase from position 17 onwards, for example. I can find certain things, which we already did. Find first stuff, find not, last but not with some other criteria. Uh, I can insert text, but I'm trying to figure out where I thought replace would be easier than this. Okay, Let's have a look. It's a templated class. Okay, that's 10 overloaded things. Hmm. Let's try one more thing. Um, but I've also tried a, well, maybe I may be able to try a quote as well. I want to try this. I'm going to obsess a little bit because that's what I do. You find uh, new text. Hi. My syntax here could have been wrong, so let's find out if that works. Does it work? No, it's not working for me. None of it matches the arguments with string and a string. That's fine. So this is what the arguments it's expecting. It's true. And then but it's looking for iterators. So I'm going to leave it alone for right now because it's going to get real ugly otherwise. Oh no, I should have actually done this one. Other options I could have done. I could do the same thing as I did last time, but that's me doing my own thing. There's a lot of times they've already invented the technique in order to do this. But let's do it anyway. So let's make a function called replace all, and it's going to take in uh, per word. It's going to take in to find, and I'm going to make a new function of my own. Screw it. All right, and then I'm going to output it. All right, let's make a new function. The new function is going to be called replace all, and it's going to return. It's going to return a string. I could do this. And string main word. Something like this. Okay. So I'm going to make a brand new function. I'm just playing with some things to show you different examples. That's why it's sort of haphazard because I want to just show you different things. So in this case, I'm going to have a bunch of strings. I'm going to find a particular string. I'm going to do the same technique as I did last time, which is just replace all instances of that particular string with the new particular thing. So I'm going to just take my old code to a certain extent. So where are we here? Um, okay, and that should do. All right. I want to find the thing to find is found pause is equal to, okay, I'm going to be finding to find if found pause is less than main text dot length. I'm going to, then this is, I'm going to go from there to found pause. Uh, okay, pre pause. It's going to be post pause. And my new line is main text. Right. And then okay, then I'm going to do the same thing again. I'm just going to find that same string again. And at the end of the day, I'm going to return. All right. And so replace all, it's going to be per word is equal to that. All right. So this thing is going to put dashes everywhere where I had white space, and everywhere else, then it's going to, for each one of those things, uh, so it's going to append a dash, and then it's going to find L question marks, replace it with an exclamation point, and then output each of those words one after the other. Okay. I don't know how slow this is going to be, so we'll find out. I got an infinite loop in here. Gotta stop it. Unless I don't have an infinite loop and I just had a breakpoint issue. But I think I have an infinite loop. All right, let's find out what happened. So I'm going to get each individual word. I'm going to put it in the current word. I'm going to append the dash. Then I'm going to make these two new strings, replace with this, and I'm going to replace all. Okay. I think my problem is going to be right in here. All right. Sound pause is equal to this. Okay, let's find out what happens. Because I suspect, strongly suspect, we have an infinite loop right here. Oh, let's just slow. No, it's not breaking anywhere. So, yep, we got something else wrong. Let's find out. Boom. Okay, it stops there. It's going to go number lines. I'm going to open those files. I'm going to get my current string, the end of the file. So at the end of the file, I'm going to get the current word. It's this thing. I'm going to append a dash at the end. So notice what current word is. It is now dash dash slash dash dash. I'm going to make two strings. I'm going to, let's see what happens here. I'm going to go into replace all. If I found this value, it is less than this, so I should be done. And I return main text, okay, which means current word is equal to what it was before. And I'm going to output that. In fact, it's the cout statement that's the problem. Let's try this out. There we go. Silly thing. Okay, that was a glitch in Visual Studio, I think. All right, end of file. I'm going to get my current word. I'm going to attach dash. I'm going to make these two things. I'm going to see now, and then I have the word now with a dash in it. Okay. And I'm going to just, what I'm going to do is just let it ride. Let's find out. Let it ride. Hey, it actually worked. Good. Do I have any question marks in here? Self-space as is, and why is this not commented out? Should be, oh, commented out. There we go. We are in the replace all. Replace int, and a string. It might be. Ooh, so I keep on seeing iterator, which iterators can be a whole bunch of different things, not necessarily an integer. We should try that. I want to see that if that works. So that would be where it's the between starting at this point, ending at this point, replacing. And what would so what are the parameters for you, Sean? Int string suggests you're replacing something with something, but you don't have two strings in there. You only have one string in your parameter list. So int one with int two, it could be that. Honest to God, it's one of those things I would have to look it up. It's like the tokenizer. Anytime when you're tokenizing things, you have to look it up and just figure out how the heck somebody else implemented this thing. Okay, which is part of what we're trying to teach. Honest to God, it's not by accident. It's intentional. That is one of the things when we did faculty candidacy talks. They're saying, what should every single student be able to walk away from a university degree from this program being able to do? And one of them was like, look up the documentation. Which is terrible, but that is what we do. Uh, just being comfortable enough, having been exposed to enough of this stuff to know where to start looking and how to process this is part of the skill set we're trying to teach, because it is what everyone just does. All right, so let's see, pre, post. Let's see here. I have my main text is out question mark question mark. The pre is out. The post is should be question mark with a dash. So my main text is now out question mark dash. I find it again. I go back in, pre, post. Main text is now once again equal to out and a dash. Found position is a huge number, so it's negative. It's outside of the range, and I return main text. All right, this should actually work. I'm shocked. I truly am. Here we go. Hey, it worked. Here we go. All the original text, no question marks, with a dash in between everything. If you need replace and you're really dead set on it, great. Tell me how it works as well, right? Sometimes it's faster to roll your own, not always. But most of the time, I wanted to point out that there are things you can do just that are pre-built into the string class that you can use, like substring, like find, like length, like append, like insert. There's a bunch of different functions that you have available to you that you can play with. And read line or yes, read line gets an entire line of text. Your cout statement, your cin statements work just like scanf and printf. The only difference is you have these chevron things, these pointy arrows, instead of having a particular function call. So if I want something fancy, like let me see if I have a fancy one in here. There we go. Not overly fancy, but if I have a whole bunch of parameters, it's cout, then some text, then the thing I want to put in, then some text, then some other thing I want to put in, then some text. Instead of having this like percentage %s and percentage %i thing, I just insert them in a row. Sometimes it's faster, sometimes it's slower. Sometimes it's faster. Instead of using a cout statement, make a string object and then output the string after you're done, when you've done all the processing for it. This assignment is designed for getting used to this sort of thing and playing with how strings work. You'll also notice one other weird thing about strings I want to point out. I think we have an example here. Here we go. This is a pointer to a string. Works just like pointers everywhere else. The only reason I would want to do this is if I want to actually manipulate the original string. Right? I pass in a pointer to the string and I can now change the string and it reflects in whatever function called it. I don't have to pass the string back. I could just manipulate the string directly. Just like passing in an array, you can manipulate the array. But when I do this, and let's see if I have an example of, there we go. Every time I have a string, once again, just to remind you, just like with a struct, instead of a dot, I'm using the arrow. So much like a struct, if I have a pointer to a struct, I use an arrow. If I have it's a straight up struct, I use a dot. It's going to be the same syntax when it comes to classes and objects. When I need a particular variable or a particular function, I use a dot, unless I have a pointer to the object, in which case I use an arrow. It looks the same. You'll just get used to it. And in fact, here's the wild thing that I sort of love about this. So let's try it again for this right here. So P text line. Visual Studio gets better all the time, not like back in my day. And then I want to get the length. So just in case you forgot what to do, it changes it for you. I put in a dot, it gave me an arrow. It said, no, 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 I know what you're doing. You're dealing with a pointer. Here's an arrow. Great. It's auto-correcting it for me, just in case you get into that particular habit. So even if you don't remember the arrow, you can just put a dot and it'll fix it for you, which is nice. Okay, I've been talking nonstop for over an hour over, I think there was like 3 words that someone wrote: strings, the assignment, get line, and then I gave you all of this. So let's make sure everyone's feeling comfortable with other stuff. If there's any other questions or any clarification, I'm hoping it is helpful. That's the whole point of the synchronous lectures is we were told to do asynchronous as the right way to do it. And it also let me do it over the summer and record these videos. You'll notice I'm wearing like a t-shirt in some of these videos, but there's no replacing this sort of back and forth where you guys ask me questions. That's where the real learning is. And it's really frustrating to have to do it asynchronously. Um, so I'm hoping it's helpful. Is there other things that you're still like unsure about? I want to get rid of that line, by the way. So in case you didn't catch the earlier email, the vast majority of this assignment will be you writing shift text CPP, which looks very similar to what we just did with the replacing text, wink, wink, nudge, nudge. Uh, find block end CPP, which seems very similar to find, wink, wink, nudge, nudge. And it returns an integer no less, right? The position where the end of the line was. Uh, this was given is now given to you just because I thought it got a little bit funky when it came to where things were positioned and how things were found. Um, I even found a bug, minor bug, but still a bug in my original code from last week. It removed a tab when it shouldn't have removed a tab. So it's like it now it looks like this, but it was looking like there, like that. See, tab. That's the old one. That's the new one. Found the difference because my numbers weren't coming out exactly the same. The nicety of having done this way is if I read the file correctly and remove all the comments in the CPP file, what would I expect? I'd expect identical outputs if I read in the same file using the C code and with the CPP code. Ideally, I expect identical files being output. So the same number of characters removed, the same output text line by line if you want to look at them. So you can, oh, let's see, compare this to this and see if they're the same. They're the same, completely different code being used. That's what we're looking for. So that you can, and you can do this with any file. You can pass in a brand new file, make your own file, throw it in there, see what happens. It's very nerve wracking because you think, oh God, it's going to blow up. But that's the nature of the beast. All right. Anything else? I'll let you guys go then if I have no other questions. Okay. Um, unrelated, but while we're here, for last tutorial, I was trying a malloc 2D array. Oh my God. Yeah, 2D arrays. Oh. To the point that I realize how they're very important. They're very useful, but maybe I'm pushing you guys too hard on that one. So I'm trying to remove it from the next versions of 1400. A 2D array, what does it look like? A 2D array is an illusion. A 2D array, for the most part, you can either make a 2D array by calling malloc for a whole bunch of pointers, and then for each of those pointers, making a new array. So an array full of arrays. Or I make essentially one giant 1D array, and I pretend it's chopped up in different places. It depends on how you want to do it. So if you really want to see the code on that thing, let's see if I can save that. Maybe I shouldn't have saved it, but I'm saving it anyways. Let's do, uh, let's see what I can do here. Ooh, let's do a 2D array of text. So I'm going to do void make 2D text, and let's do, so I would need an array of, it's an array of arrays. I'd like this because I don't remember anything. I barely remember my own name. Text array is equal to char pointer. it's the size of a char pointer. That's what each one of these things are, multiplied by how many things I have. Let's say this is the size. Actually, let's make this um, in width. In width would be the number of characters. Sure. And width and height, okay, something like that. And I want to make it the height. And what will this do? This will make an array of a bunch of pointers. And what's the good of that? It's not really that useful, except now I'll just make a for loop is equal to how many things do I have? Oh, it's height. That's how many things I've just put in, right? I plus plus. And now for each one of these things, a text array at position I, that is my pointer to a character array. It's just a pointer to a character, but it can be an array. So that's equal to, let's say, char star malloc size of char, how big each character is, multiplied by width. So this would be an array of characters, a simple array of characters. And I have an array of those arrays of characters. Okay. And then maybe what I want to do here is strcpy a text array position I. I'm going to put in uh, below. Do I want something else? Can I do something else? So I don't want the number, but we're just going to use below. Um, so I'm going to put hello a bunch of times. And by the way, if I'm using something like this and I know how long this string is, maybe I should put an assert to make sure that I don't go over the edge. And you go, why would I want my program to blow up if it goes wrong? Well, I'd rather it blow up there than, you know, 20 different functions later when it finally does blow up on you. You're never tracking it down otherwise. You have it blow up where the problem is. The problem here is this line of text is too long. If it doesn't fit in, blow up. So, um, so I could have something like assert uh, width is greater than strlen of below, right? I'm asserting that that has to be bigger, otherwise don't, blow up in my face. I put it there. Okay, I'll put that character there, okay? And when I'm done, what do I need to do? So I could, print out all this text, but when I'm done, what do I need? If I just delete this, what happens? If I just call delete on this whole thing, let's do that, or free, sorry, not delete. Delete's the equivalent with delete and new is the equivalent of free and malloc. So if I just call free of a text array, what happens? Well, I'll free up the big array, which has a whole bunch of just pointers. That's all it has is a bunch of pointers. So imagine like a lookup table, just a thing saying, go to this part of the library, right? The Dewey Decimal System. And you're saying, I want to destroy the library. How am I going to destroy the library? I'm going to destroy the Dewey Decimal System. I'm going to destroy the little lookup index box thing that you have at the front of the library with the drawers, that thing, right? I'm going to destroy that. That's going to clean up all the books in the library. No, that just tells you where to go. That's the lookup table, right? That doesn't destroying that doesn't remove the books in the library. You got to remove the books in the library, then destroy that lookup table. If you want to make sure, like, I want to remove all the books in this section of this lookup table. Just removing the cards doesn't remove the books. I got to go to the books, go to those cards, find where they are, remove the books, then remove the card. Find the books, remove the books, right? It's a two-part process for deleting this thing. So I'm going to do that for loop again. So let's free this thing up, and then I'll look at it with new and delete. All right. This is how many things I have. I'm not going to be using malloc. I'm going to be using free. So I'm going to free a text array at position I. And just because I'm paranoid, AA text array, it's not a bad idea to be paranoid sometimes, uh, is equal to null. Set it to null to make sure someone doesn't accidentally go, hey, it wasn't freed yet, let's free it again. Okay. And same thing over here. A text array is equal to no. Notice if I don't do this free part here and I free it here, if I free this here, do I still have access to free up those other arrays? I made those arrays. If I throw away the lookup table, there's no way to find that stuff. I get a memory leak. I need to free it. I need to free each individual part first and then give back the original. Okay. And now here's the thing that I wanted to point out. Hopefully I can do this really quickly. Mm, mm. Okay, here we go. We're going to try it as fast as we can. Uh, and this is a new char star of size height. This is a new char array of size width. That's still fine. That's effectively still fine. Bring it up. I'm going to delete. This is the weird one. I need to do that thing. A a text array at position I, and then I need to delete this thing here, and done. This is the C++ equivalent to what we did last term. It's exactly the same. It's just you change the words, and it hurts me. It almost physically hurts me to write malloc all the time because I hate it. I hate it, hate it, hate it. Malloc, why are we doing math calculations? I have the same problem with French. Sorry for any of the francophones here. When you 1990 or something like that, you're like, oh, 1990. Like, what? Stop making me do math. Come on. 1,000 plus 900 plus 9 plus, yeah, 240s and and a 19. Oh, God. Oh, and a 10 and a 9. Sorry. Right? Just it doesn't roll off the tongue very well. This thing feels the same way, right? It's like I'm going to figure out the size of those bucket, and then I'm going to no. I just want a bucket of characters. Stop asking me to call size of and do multiplication and stuff like that. Just say I want an array of 20 characters. Done. Hey, that's what we have here. I have an array of this many characters. Get out. Right? I'm done. And it does the exact same thing. So, and there's no casting on top of that. We will see this again very soon. It's completely convoluted. Um, and even calloc, same thing. It's not at least there's a comma in between, not rather than doing math, but it's the same thing, right? It's because C is so old as a language, still used. Uh, I would like to point this out, and I wish I pointed it out earlier. My your TA here for this course, Pat, brought up the fact that they can mathematically prove for most cases, if you write the code in Python, it is 400 times slower than writing it in C. Now, it's probably going to be a lot less cumbersome on your brain and stuff like that. But the reason people use C and C++ is not because it's the easiest to understand. It's because it's blazingly fast compared to other languages. It doesn't have that overhead. It means you make mistakes. It means it's hard to understand, all these kind of things. But it's fast as hell. And that's the reason people still use it. That's why we still have to keep teaching it, because it's what industry uses because it's fast. It's 400 times faster for the same code than Python. So, yeah, I love new. And the really nice thing about new is as soon as we get to objects, new is your friend, because this is the kind of thing you would do. string. Actually, I have an example. Let's just go to the example. It's given to you guys. Here we go. Here's a new object called infile. I call new the kind of object that I'm going to make. Gives me a pointer to it. And you go, why would I want a pointer? That will make sense later when we get to polymorphism and inheritance. But in the meantime, when I call new, I get a pointer to an object and I can do stuff with it. And it's mine. Until I call delete, it's mine. But notice what I call new, there's no square parentheses. And when I call delete, there's no square parentheses in the delete either. That's the one change that we have between objects and arrays. But it's new and delete. And it makes sense. And I'm going to make a new object. Here you go. Give me a new object. It's a pointer to a new object, but it's my new object and it's mine, not somebody else's. And then later on, I just call delete to free it up afterwards. That's what we get used to a lot more of. Not keeping strings around like not doing things like this, which is a local variable. That thing gets destroyed as soon as I'm done with this function. When I call new, it's mine, like a dynamic array. I keep it until I give it back, which means I can make, I can make an object like a string and have it run or passed around my entire program and not have to worry about it getting given back to the system. It's mine until I give it back, just like a dynamic array. So we'll get very used to calling new and delete on our objects as well. On objects and on arrays. It's all so much fun. Um, for assignment, just to get ahead of you, because I know you're very excited about the next assignment. Assignment 3 is the same as assignment 1. You can even just take the assignment 1 code. I don't care. That's fine. But instead of what we did with assignment 1, we'll be doing it in objects. And hope it's even easier. I'm hoping it's a little bit easier. Is just to get it rather than having a struct, your struct now knows what to do with itself. So when I make a tree node, I can say, hey, tree node, are you connected to this guy? And it goes, yep, I am. Good enough. The tree node knows if it's connected to this thing. The tree node knows if it has a path from this point to this point. How do we tell the while loop has reached the end of the file? EOF, end of file. Yeah, I had to look that up one time. Honest to God, it's a weird, like, you didn't call it end of file. You had to call it EOF to save those couple characters, but that is the name. The other option besides EOF, where is my EOF? Okay, so with this one, I know every time I call this, I'm going to get something put into this current word. That's why I need EOF. I need it for this thing. But when I was reading the line by line, if get line doesn't work as expected, it also returns some kind of error message or some kind of zero. So I'm paranoid here. I'm either at the end of the file, if I'm at the end of the file, so I'm either not at the end of the file and get line works, then keep going. So if it gets to the end of the file, EOF gets called. If it doesn't work, that gets called. Either one will stop this thing. I just double redundantly encode I did extra backup, right? It's on a Tuesday and this and this. If all those things happen, then stop. Or any of those things happen, stop. So if I get to the end of the file or get line doesn't work, stop. Next question. And I had to really wanted to show you guys EOF because otherwise it sounds like an EDM group. Because when I did it, so your EOF doesn't stop it. You need the get line. Because I wonder if mine did that too. One little, uh, it doesn't stop at all. Even when you do get line each time, it has to stop. Now, if you do get line and you forget to do get line each time and you're doing it, you have some other means here other than this exact format, it's not going to work. All right, like if you have get line, the next line in, and you're not checking for that get line, then it might go on forever. Um, you'll have to send me the. I think you may have to send me the code on that one because that seems. If your thing keeps going despite the EOF check and despite checking to see if get line actually works, I honestly don't know how it would. I wouldn't stop. It's you're running out of track, and oh, you can't show me your code though, unless it's oh, it's yeah, it's to everyone. Let's can you delete that, and then or I don't know if that's I don't want people seeing your code. That's all. Oh, okay, good. That's fine. Uh, can I just want to view it. Uh, Oh, hmm. And it just keeps going afterwards, right? 4692. It's doubling each time, right? Yeah, it's just a double each time. So if it's just doubling each time, why is it doubling each time? If it's just reading a new line of text, it wouldn't double. It would just incrementally increase. I would have to look at the code, I think. I'm going to eat supper in a second, but you can send me the code as a private DM and I can have a look at it if you want. Right? I want to make sure that you guys, I always go long. I know I do, but I want to make sure that you feel comfortable with what we're covering so far. We've covered a lot of stuff. We've covered a lot of ground tonight. I'm going to post this to make sure it's posted for people online later this evening. But I'm hoping this was useful in some way, shape, or form. Um, and then when we get to the next assignment, we get to make objects finally. We get to do real C++ code. I'm very excited. All right. I'm going to stop there then. Thank you guys very much for listening, and hopefully have a great night. No problem.